Grade 12, welcome back once again to our sessions. It's still the Grade 12 Mathematics Summer Lessons, and this is our session 6. Okay, so today in session 6, we'll be doing quadratic sequence and combinations of arithmetic and geometric sequence. Okay, Grade 12, let's take a look at the content outline as we always do. Today's session 6, and if you check in session 6, you are expecting that we should be doing the practical applications of sequence and series. But no, I just thought I should put that in the last session, which will be session 7. So today we're going to be dealing with quadratic patterns, and this is a revision because you already did this in the previous grade, I think in grade 11. And also we'll be focusing on combinations of arithmetic and geometric sequence and sort of like a different style or strategy they use there in solving those combined geometric and arithmetic sequence. So we are still on unit 6. I mean, we are at unit 7, but it's session 6, right? We just swap, so we can say we're still on unit 6, where we'll be not focusing on practical application, but we'll be focusing on something in unit 7, which is quadratic patterns, which is a revision and combination of arithmetic and geometric sequences. Okay, so don't forget we are still using the textbook, Platinum Mathematics Learner's book, and that's the textbook that we'll be using throughout these sessions. And I just thought we should put this to give credit to also the writers and all people involved there. Okay, unit 6, quadratic sequence and combination of arithmetic and geometric sequence. But here in this slide, I just want us to focus only on a quadratic sequence. Okay, so in grade 10 and 11, you learn about linear and quadratic number patterns. So in linear number patterns, if you remember our session 1, it was arithmetic number patterns, and they have a constant difference between the consecutive terms, right? While in a quadratic number pattern, they have a constant second difference, right? So you'll first get the first difference, then your second difference are the ones that are going to be common or constant, right? So don't forget, this is a revision of a quadratic number pattern as you learned in grade 11 mainly, and also in grade 10. So in grade 11, we dealt with quadratic number patterns having the general term of the form Tn is equals to an squared plus bn plus c. So this is the general formula or the nth formula for the what? For the quadratic sequence. And let's just explore some example in order for you to just recall this this kind of sequence. Okay, so the question says, it's our first example. Question says, consider the following number pattern 2, 3, 6, 11. Determine the nth term, that is the general term. Don't forget, this is a quadratic sequence, right? So this is a quadratic sequence. Don't forget. They said determine the nth term, that's the general term, and hence determine the value of the 42nd term. So we already saw in the previous slide that our general formula for quadratic sequence is n squared plus bn plus c. So we have to determine a, b, and c, right? So don't forget, in a quadratic sequence, we have a constant second difference. It means we have to first get the first difference, then we get the second difference, and we must see our second difference must be the same. So we have 2, 3, 6, 11. So if I get the difference, 3 minus open brackets 2 is gonna be 1, and 6 minus open brackets 3 is gonna be what? 3, and 11 minus open brackets 6 and it gives me 5. This is the first difference, right? The first what? The first difference. So don't forget, in a quadratic we have the second common difference. So we must get the second difference. 3 minus open brackets 1 is 2. 5 minus open brackets 3 is 2. So this is our what? Second difference. Second difference. And you can see the second difference is the same, is 2. So how do we now go and get the value of A, B, and C? Very simple. So now the second difference is equals to 2A. So you say 2A is equals to your second difference. Then 3A plus B. Your 3A plus B will be equals to term number 2 minus term number 1. And your A plus B plus C will be equals to term number 1. So that's how you're going to solve for those unknown. From bottom going upward, right? So I'm going to say 2A is equals to my second difference, which is 2. Divide both sides by 2. My A gives me 1, right? So A is 1. We go on top. 3A plus B is equals to 1. That is term 2 minus term 1. So where there is A, we already calculated, and it's 1. Then I'm going to solve for B by taking my 3 to the other side. Then B will be equals to minus 2, right? A plus B plus C is equals to the first term, which is 2. My A is 1, my B is minus 2, plus C is equals to 2. 1 minus 2 is minus 1, plus C is equals to 2. Then C will be equals to 2 plus 1, which is 3. So now I got my value of A, B, C. Then I can write, therefore, the general term is A, which is 1. It will be just n squared. 1n squared is 1n squared. B is minus 2. It's going to be minus 2n plus C, which is 3. So this is the general formula. And that's how we actually calculate it, right? So you must know this formula here. Which one is equals to which one is equals to which one. Then you just solve from bottom going on top. They said hence determine the value of the 42nd term. So this is term 42. Where there is n, we're gonna substitute by 42. Then we solve for our term 42. Okay. And our term 42 will be 1683. So that is the value of, oh, sorry about this line. So that's the value of term 42. Okay. Okay, let's move now and do B. So don't forget, we got our Tn as n squared minus 2n plus 3. And yeah, and our term 42 was 1683. Don't forget. Determine which term will be equals to 1091. So they want to know which term in the sequence will be equals to 1091. So actually they want to know the position of the term. So they want n when Tn is equals to 1091. So our Tn it was n squared minus 2n plus 3 is equals to 1091. If we take 1091 to the other side, we'll have minus 1091. And 3 minus 1091, it's n squared minus 2n. 3 minus 1099, it's 1000 minus 1088 is equals to 0. So we can use a quadratic formula in order to solve for n. It's going to be minus b plus or minus root of b squared minus 4ac divided by 2a. Right. So n is going to be equal to minus our b is also negative, negative 2 plus or minus root of our b, which is minus 2 squared minus 4. Our a is 1, c is minus 1088. Okay, divide by 2 into a, which is 1. Okay, so we're just going to use the formula and solve for n there. Okay, when you solve for n is going to be equals to 34, or n is equals to negative 32. So don't forget, we said n cannot be negative because n stands for the position and it's always the element of a natural number or a positive whole number. So for n equals to 32, we're gonna write not applicable. It's very important to write that. So, and also to conclude, n equals to 34 only. So it means that the term which will be equals to 1091, it will be term 34. Term 34 will be equals to 1091. Okay, so that's basically how we do that. Okay, let us consider this a different example. It's the quadratic sequence, but it's those quadratic sequence where you are given the terms in terms of variables or unknowns. And the first question, just like in Arithmetic and Geometric sequence, will go like solve for that unknown. So question 1 here, it's solve for x. So how do we solve for x if we are given a a quadratic sequence? Okay, what do we know from a quadratic sequence is that we have the first difference, which forms the linear sequence, and we have also the second constant difference. So we need to get the second difference and equate them, because we know that the second difference are constant, or they are the same. So I'm just gonna write my sequence here: minus 6, 2 minus x, 4, and 2x plus 5. And I'm going to be getting the difference, and to get the difference, I say the following term minus the previous term. So it's going to be 2 minus x minus, don't forget, after a negative, you put whatever follows in brackets to avoid making mistakes. Here it's going to be 4 minus into 2 minus x. Oh, sorry about this line. And okay, let me put this on properly. 4 minus into 2 minus x, and here it's gonna be 2x plus 5 minus into 4. Then I'm just gonna simplify that very fast. It's gonna be 2 minus x, minus and minus is gonna give me positive 6. So this is minus x plus 8, because 2 plus 6 is 8. So here it's going to be 4 minus 2 plus x. When I remove by negative, then I'm left with x plus 2, because 4 minus 2 is 2. Then this side, I'm going to be left with 2x plus 5 minus 4, and this is 2x plus 1. So these are my first difference. These are the first difference. So they form a linear sequence, right? So we know that the second difference, they need to be constant. So we can get the second difference by saying x plus 2 minus into minus x plus 8. Don't forget that after a negative, put whatever follows in brackets. Very, very important. Here to be 2x plus 1 minus into x plus 2. Then if I simplify, it's x plus 2 minus and minus plus x minus and positive minus 8. X plus x, 2x, 2 minus 6, 2 minus 8 minus 6. So this is one of my second difference. This side is going to be 2x plus 1 minus and x minus and 2 minus 2. 2x minus x is x. 1 minus 2 is minus 1. So this is my other second difference. So I got my second difference. How do I solve for x? We know this is a quadratic sequence, and the second difference are the same. So they are equal. So I'm just going to say 2x minus 6 is the same as x minus 1. Can group 2x minus x, then minus 1 plus 6. Then 2x minus x, it's x, It's gonna be equals to 6 minus 1 is 5. Then our x is 5. So that's basically how we solve for x if we're given a quadratic sequence in terms of x. Okay. Let's go to number 2. It says determine the nth term of the sequence, right? So before determining the nth term, we can substitute a value of x and we just get the sequence in terms of numbers. So where there is x, I'm gonna put 5. Everywhere where there is x, I'm just gonna put 5. And let's see how our sequence will be. To be minus 6, 2 minus 5, minus 3. We have 4. 2 times 5, 10 plus 5, 15. Okay, so this is our sequence. Then we can get the first difference, minus 3 minus into minus 6, here to be 4 minus into minus 3, then here to be 15 into 4. Minus 3 plus 6 is going to be 3, because it's 6 minus 3, so positive 6 plus 3, like that. So 4 minus into minus 3 is minus and minus, positive 4 plus 3, 7. 15 minus 4, this is 11, and this is our first difference. Let's get our second difference. 7 minus 3 is 4. 11 minus 7 is also 4. So this is our second difference, and we can see that our second difference is constant or is the same. Okay, so how do we get our Tn? You know that Tn is equals to an squared plus bn plus c, right? Okay, so to get our a, we say 2a is equals to second constant difference. Then we say 3a plus b is equals to t2 minus t1. Then a plus b plus c is equals to term number 1. So if we say 2a is equals to 4, then we know for sure that our a is going to be 4 over 2, which is 2. Okay, so 3 into a, which is 2, plus b is equals to t2 minus t1, which is 3. So b is gonna be 3 minus 6. 3 times 2 is 6. Take it to the other side, then b is gonna be minus 3. Okay, a plus b plus c is equals to what? Term number 1, which is what? Minus 6. So 2 minus 3 minus 1 plus c is equals to minus 6. C is equals to minus 6 plus 1. C is equals to minus 5. Then we can get our Tn. Just gonna put it on top. Tn. Tn is gonna be what? A, which is 2n squared. B, which is minus 3n. Then our C, which is minus 5. So this is our Tn. Okay. Okay, number 3. So number 3, you're gonna use it as your fun activity. Just pause the video now and look at number 3. It says which term has the value of 400, and just drop your answers on the comment section, then I will respond from there. Okay, great stuff. Let's move to our second part of this session, and this is mainly about combination of arithmetic and geometric sequence. So this is a tricky part of this session, and I really want you to be very attentive, because that's where most of our learners get confused a bit. Okay, so this is a combination of arithmetic and geometric sequence in the same sequence, right? And with the given example that I've just displayed on your screen right now, this will basically help you to understand how you can solve questions related to combination of arithmetic and geometric sequence. And I will further move this session just to enhance your understanding with 2 more examples, because it's not only about combination of arithmetic and geometric sequence. Sometimes they can combine arithmetic and arithmetic sequence. It's just that it will be sort of like a different arithmetic sequence with its own common difference, and another different arithmetic sequence with its own common difference. Sometimes they might combine geometric and geometric, right? But having different common ratios in the same sequence. And it's very, very important that you should be able to identify or to know how to identify when they have combined two sequences. So this first session is about combination of arithmetic and geometric sequence, right? I mean, this first part is about that. Okay, so they said the following sequence is a combination of an arithmetic and a geometric sequence. So this statement that is given in this example, it's very rare that you'll get it in your exam unless they just want to just break down the complexity of the question. They might just give you that, but most cases they'll just give you a sequence like this and they keep quiet, and what follows will just be questions, right? They just say given the sequence 5 5 15 10 25 20 35 40, then they say uh uh uh, determine then they just ask you these sort of questions, right? So let's assume they didn't give you this statement, right? And they just give you this is your sequence and they want the next two terms. So basically what every learner has to do, they have to first check, is this an arithmetic sequence? And how do you check? You calculate the difference between the terms. If the difference is the same, if it's common, T2 minus T1, if it's equals to T3 minus T2, definitely it's an arithmetic sequence, right? But if you get that the difference are not common, not arithmetic, you go and check ratios, the ratios. T2 divided by T1 must be the same as T3 divided by T2. If it's not the same, then it's not geometric, right? After you find that it's not arithmetic, not geometric, you go and look out for quadratic, whether it can be quadratic. And how do you determine? You calculate the first difference and you get the second difference. If your second difference are the same, definitely it's a quadratic. But if they are not, definitely not quadratic. What do we do after we have checked that this sequence is not arithmetic, this sequence is not geometric, this sequence is not quadratic? What do? We go and check whether this is a combination of arithmetic and geometric, or arithmetic and arithmetic, or geometric and geometric, like that, right? How do we check? Very, very important. So in order for you to check whether it's a combination, what you do, you are going to highlight certain numbers on a sequence, right, in that order. So you'll highlight the first one, you skip the following one, highlight the following one, you skip the other following one, highlight the other one, you skip the other following one, you highlight the other one, you skip the following one, like that. After you have highlighted them, put them on a separate piece. Just write them separately and check if whether they don't form a sequence. So those ones that are in between, that are not highlighted, also put them as like in the same sequence and check whether they don't form a certain sequence, right? So after you have separated them like that, you can now check whether which sequence is this, which sequence is this, then you can start answering the question. So with the one for red, we can see like there's a common difference of 10 in between, right? If you check 15 minus 5, 10, 25 minus 15, 10, 35 minus 25, 10, common difference of 10. Okay, sorry about this. There's a common difference of 10, and let's look for the one in black, that is the one in between. Let's check if so the one in red, if there's a common difference, we can conclude this is an arithmetic sequence. The one in black, let's check now if there's a common ratio. We're just gonna take the following term divided by the previous term, following term divided by the previous term, and we check 2 is equal to 2. Also here it's equals to 2. So we have a common ratio. The one in black is the geometric sequence. Now we can conclude that this sequence was just a combination of arithmetic and geometric, right? So after you have done that, it's now easy to answer the questions. You can just go now and answer the questions. Are we going to do 1.1? It says write down the next two terms, right? Write down the next two terms. But before writing down the next two terms, we have to know that the next term here that is following, is it going to be for arithmetic or geometric? The next term here that is also following, is it for arithmetic or geometric? How do we determine? It's very simple, right? We already know that the one in red is arithmetic, the one in between is geometric. So it's saying arithmetic, this is arithmetic, then geometric, arithmetic, then geometric, arithmetic, oh, sorry about that. I think I made a bit of mistake. So it's arithmetic, geometric, arithmetic, geometric, arithmetic, geometric, arithmetic, geometric. So the one that is following here will be arithmetic, then here will be what? Will be geometric, right? So we need to determine the next term for an arithmetic. We go on an arithmetic, then we check how do we get the next term there. We say the previous term, we add the common difference, so it will be 35 plus 10, which is what? Which is 45, right? So the next term is 45. Let's get the next term for geometric, because the other next term here, it is for geometric. We'll say 40, the previous term multiplied by the common ratio, times 2 is going to be 80. So these are our next two terms, 45 and 80. And I hope you understood how we do that. Okay. Okay, 1.2. Calculate term 42 minus term 41. Very challenging question. Quite challenging, but I hope you will understand it after this session. T42 minus T41. How can we calculate, or how can we get this difference if we don't know whether T42 is for arithmetic or geometric? Remember this combination, whether T41 is for arithmetic or geometric. Very important. So we need first to know, is term 42 an arithmetic or geometric sequence? Part of an arithmetic or geometric sequence. Is term 41 part of an arithmetic or geometric sequence? We need to know. And how do we know? We check the positions for our sequences. We check the position for arithmetic sequence to check if it's sitting on a position where it's like it's a position for even numbers, or it's like for odd numbers. What do I mean? I'm saying we check whether our arithmetic sequence is sitting on position. If it's for even numbers, obviously it must be sitting on position 0, 2, 4, 6, 8, 10, 12, like that. But if it's sitting on position for odd numbers, then it must be 1, 2, 3. I mean, it must be 1, 3, 5, 7, 9, like that, right? So that's basically what you check. Then you'll be able to know, because 42 is an even number. Definitely, if our arithmetic sequence are found on even number position, then we know 42, term 42 is for arithmetic, like that. If it's sitting on odd numbered position, we know term 41 it's for arithmetic, like that. Okay, let's check. Arithmetic sequence is highlighted in red, and you can see it's on position 1. We skip 1, 2, 3. It's on position 3. We skip 1, 2, 3, 4, 5, like that. You can see that arithmetic sequence are sitting on position for odd numbers, like 1 on position 1, position 3, position 5, position 7, like that. It means that because 41 is an odd number, this term will be for what? For an arithmetic sequence. Definitely geometric will definitely take the one for even numbered position, because if you check, geometric is the one in between, it's on position 2. The other geometric is 10, it's on position 4. It's for even numbers. So T42 will be for what? For geometric sequence. So now after you have identified, we can go and calculate, but we are not yet done. There's still sort of a bit of a trick, right? So now the mistake that most students will do, I said this is for geometric sequence. The mistake that most students will do if they want term 42 with combination, they'll just go, okay, because this is for geometric sequence, term 42 is AR exponent 41. Okay, this is correct, right? But not when they've combined two sequences. Remember, this is a combination of arithmetic and geometric. So now term 42 on arithmetic, term 42, it's 42 on the whole combination, right? But in a geometric sequence, it is not number 42, right? It's definitely something assigned. How do we know? A simple way to know this, you just check. Okay, let's say term number 2, right? If you check term number 2, it's a geometric sequence. It's part of a geometric sequence. But on the geometric sequence itself, on the whole combination, it's in number 2, right? 1, 2. But on a geometric sequence, it's the first term. It's like 5 there. It was term 1 of a geometric sequence. So you have to be very careful about that. So how do we do? It's a simple method. If they've combined two sequences and they say determine term what, you simply divide to know it is found on which position, you divide by 2. So I'm gonna say 42 divided by 2, then it's gonna give me what? 21, right? So 21. So it means that term number 42 on the whole sequence, when we combine, it's in position 42, but on the geometric sequence, it's in position 21, right? It means its n is what? It's 21. So to get it, we'll say what? Because its n is 21. So to get it, we'll just say AR exponent 20. Then you get the answer for term 42. Very tricky. So you have to be very careful when they are combined. How do you do? Just simply divide that number 42 by 2, because there are two sequences. So 42 uh, is not uh, it's not basically on that geometric sequence, but it's on the general combination. So to get the position itself on that sequence, specific sequence, you just divide by 2 and check. Right. Okay. So now term 41, because we have seen that term 42 was for geometric sequence, but on its sequence itself it was number 21. Term 41, definitely if we say 41 divided by 2, you'll get something like what? You'll get something like 20.5, right? Say 41 divided by 2, get something like 20.5. If you round that thing, it will also give you what? 21. So it shows that term 41 on an arithmetic sequence, it's in number 21, because when we divide 41 by 2, we're getting 20.5, which is probably 21, right? So it's in position 21 on an what? On an arithmetic sequence. So how do we get term 21 on an arithmetic? We say 8 plus 20. So that's basically how we're gonna do, and we're gonna substitute and get the answer. Right. Okay. What is our A? Our A is 5. What is our R? We calculate it as 2 exponent 20. Then you can get the answer. 5 into 2 exponent 20. Then it's giving you 5, 2, 4, 2, 8, 8, 0. So that's that big number. So what is my A on arithmetic sequence? My A is 5 plus 20. What is my D? My common difference. So it's 5 plus 20 into 10. This is gonna give me 205. So these are the 10, 42 and 41. But let's calculate the answer. They say calculate 242 minus 241. It's gonna be 524. 2880 minus 205. Then you're gonna get the answer. This is 5242880 minus 25, and it's gonna give me 5242675. So that's the difference of term 42 minus term 41. Very tricky, but I hope you understood. Okay. Okay. 1.3. Determine the sum of the first 50 terms. Don't forget, we are dealing with a combined sequence, right? We have an arithmetic sequence and we also have a what? A geometric sequence. So if we want to determine the sum of the first 50 terms, you know for sure that we have two different sequence, arithmetic and geometric. So the first 50 terms obviously will have the sum of the first 25 being for what? For arithmetic sequence, plus the sum of the other 25 being for what? For geometric sequence. So be very, very careful if you are dealing with a combined sequence. So your n is not really 50, so you have to split it according to the sequence that you have. We have two different sequences. Obviously 25 terms are for arithmetic, 25 terms will be for geometric. So for arithmetic, we know the formula n over 2 and 2a plus n minus 1d. I'm just gonna use this formula. And for sum of a geometric is a into r exponent n minus 1 over r minus 1. Okay, number of term 25 over 2, 2 times what is our a? Our a is 5 plus n minus 1. What is our d? So our n is 25 minus 1. What is our d? Our common difference was 10. If you check the red pen there on top. Plus, what is our a on a geometric sequence? Remember, this is a geometric sequence. Our a is also 5. What is our r? Our r we calculated it as 2n is 25 minus 1 over 2 minus 1. Okay, so we can get the answer of that. I'm just gonna get the answer for arithmetic. We add it with the answer for what? For geometric. Okay, when we get the answer for arithmetic, I'm getting 3,125. So the sum of geometric, I'm getting 16,777,2,155. Right. So if we add the two, let me see very fast. It's gonna be 16,777,5,280 as the final answer for the sum of the first 50 terms. So don't forget, we were dealing with what? With combination, and we said if you need to get the sum of maybe the number of terms that they have given you, you have to split it into two. You get the sum of those ones, and you get the sum of the other sequence like that. Okay. Okay, 1.4. Prove that all the terms of this infinite sequence will be divisible by 5. So how do we prove that all the terms are going to be divisible by 5? So you simply calculate the general formula, and from the general formula, you simply have to show them that your general formula has a common factor of 5. So once you show them that, you have actually showed them that all the terms will be multiplied by 5, it means that definitely they're gonna be divisible by 5. So that's how we do. So because we have two sequences, we're just gonna show them the Tn for arithmetic, and we show them that can we take out a common factor of 5 and can all the terms be multiplied by 5? Once we show them like that, then we've proven this, right? So just gonna use a red pen for the one for arithmetic. It's Tn equals to a plus n minus 1d, and our a is 5, n minus 1, our d is 10. This will be 10n minus 10 plus 5, then this will be 10n minus 5, right? This is our Tn, but we have to show them that all the terms will be divisible by 5. That is, you have to show them that this thing can be multiplied by 5, or 5 is a common factor. If we take 5 as a common factor, is it possible? We'll have 2n minus 1, right? So once you show them that Tn in that way, you are basically saying all the terms here, all the terms for any value of n, all the terms are going to be multiplied by 5. It means that all of them will be divisible by 5, right? Then that's how you prove. So because we have two sequences, let's also show them for what? For an arithmetic, for a geometric one, which is a r exponent n minus 1. What is our a? Our a is what? Is 5. What is our r? Is 2 exponent n minus 1. This is simple. We don't need to take out the common factor. You just show them the formula. This 5 is showing us that all the terms are going to be multiplied by 5. It means also they can also be divisible by 5. So that's basically how you show them, right? Okay. Okay, let's explore a different example of combinations, right? And let's see if this is a combination of what and what and what and what. So they say evaluate the following. In other words, they're saying determine the sum of this series, right? But we have to first check, is this arithmetic, is this geometric, or is this arithmetic and arithmetic, or is this geometric and geometric, right? So you have to check really. So if you check, you won't get the common difference if you want to check the difference, because immediately 2 minus 1 it's 1, 4 minus 2 it's 2. So there's no common difference there, right? Okay, let's check if whether it can be uh, geometric, because if we say 2 divided by 1, 4 divided by 2 of, and also if we go further and say 5 divided by 4, this is 2, this is 2, but this is 5 over 4. So there's no common ratio, right? Although the first two were showing like there was a common ratio, but as we move you find that there's no common ratio, so it's not geometric. Now think of what? Combination. So if it's combination, what do? You highlight the first term, you skip the following, highlight the second one, skip the following, highlight the other one, skip the other one, highlight like that, skipping like that, right? So then you separate them and you write them separately. It's 1 plus 4 plus 7 plus 10 plus 13 like that. Then the other one in between is 2 plus 5 plus 8 plus 11 like that, right? So we can check which sequence is this, which sequence is this, right? So this one was those one in circle and this one are those one not in circle. So 4 minus 1 is 3, right? 7 minus 4 is also 3. 10 minus 7 is also 3. 13 minus 10 is also what? 3. So we can see this one in circle. It's an arithmetic sequence. Let's check this one. 5 minus 2 is 3. Is it 3? Yes. 8 minus 5 is also 3. 11 minus 8 is also 3. So also this one is an arithmetic sequence, but it's sort of like a different sequence, but it's an arithmetic sequence also, but they both have the same common difference. So the question said calculate what? The sum. When they say evaluate the following and they give you a summation, they need the answer of the whole sum, right? So because now you can see we have, it's a combination of an arithmetic and an arithmetic sequence, right? So we need to get that sum, right? Okay, so how are we gonna get the sum? So to get the sum, Sn equals to n over 2a plus last term, right? We need to know the number of terms that we are adding and also the last term, right? We need to know the number of terms and also what? And also the last term, right? So if you check on this one, which is like 1, 4, this one highlighted in circle 1, 4, 7, 10. They are sitting on a certain position. Position number 1, position number 3, position number 5, position number 7. So they are sitting on a position for even for odd numbers, right? It means that if we want to check which one it's gonna be like their last term between these two, because between these two there's a last term for arithmetic, the first arithmetic, let me call it arithmetic 1 and arithmetic sequence 2. So in order to check, we can actually calculate the general formulas and go and substitute and see if it's a term in that sequence, right? So very important. So I'm gonna calculate, I'm starting with arithmetic sequence 1, which is the one in the circles. So Tn is equals to a plus n minus 1d. And I'm going to check whether 100, this one is a term in arithmetic sequence 1, or 98 was actually the one for that one. So our a here in arithmetic sequence 1 is 1 plus n minus 1. Our common difference is 3. So it's 3n minus 3 plus 1. This is 3n minus 2. So I'm gonna check, right? Is 100 a term in this sequence, arithmetic sequence 1? So I'm gonna check. So this will be 102 equals to 3n divided by 3 divided by 3. then my n is equals to 102 divided by 3. My n is equals to 34. So it's a n is a natural number which is a positive whole number. So it shows that 100 was a term for arithmetic sequence 1. So we can see that the last term for arithmetic sequence 1 there is what? Is 100. Definitely 98 is going to be the last term for arithmetic sequence 2. So did you see how we check? You just calculate the general formula and you equate it to 100. You solve for n. If our n was maybe equals to not a natural number or not a positive whole number, maybe something like 3/2 like that, or a number that can bring us decimal, a number that does not represent a position, or actually not an element of a natural number, and if it is not a positive whole number, then we were going to say no, 100 is not a term in that sequence. But because we got our n as a natural number like that, then we are saying 100 is a term and it's a last term for arithmetic sequence 1. So that's why if you check the red pen here, if you check 100, I put it as the last term on arithmetic sequence 1, and 98 because definitely after arithmetic sequence 1 we have arithmetic sequence 2 like that. So it means 98 is the last term for what? For arithmetic sequence 2. Okay, so that's it. So also we have also determined how many terms are there, right? We know that the number of terms, if 100 is the last term, we have 34 terms in arithmetic sequence 1. So in arithmetic sequence 1, we have 34 terms that are being added together from 1 up until 100, if moving in that sequence. Let's check on arithmetic sequence 2, how many number of terms are there. So we have to determine our general formula and equate it and solve for n. So our Tn, I'm going to put 98 because we need to know how many terms are there, plus n minus 1, our common difference is 3. So our a here is 2, right? So that's why it's very important so that you can separate them. 98 equals to 2 plus 3n minus 3. So 2 minus 3 is minus 1 plus 3n, 98, 99. When 1 goes that side equals to 3n. Then n is going to be 99 divided by 3, which is going to give us 33. So you can see in arithmetic sequence 1, in arithmetic sequence 2, we have 33 terms that are being added together. You can see, right? So after getting the number of terms and the last term like that, we can go and calculate the sum of the whole thing, right? It's sum of two things really. So it's the sum of arithmetic sequence 1 and the sum of arithmetic sequence 2 in the same sequence. So that's why these questions are quite challenging. So here I'm getting the sum of arithmetic sequence 1, and I'm also going to get the sum of arithmetic sequence 2. So in arithmetic sequence 1 we have 34 terms, right? So it's going to be 34 over 2. What is our a? Our a is 1. What is our last term? Our last term is 100. So I can get the sum there, right? So 34 over 2 into 1 plus 100. So this will give me 1770 as the sum of arithmetic sequence 1. So let me also determine for sum arithmetic sequence 2. So it's sum of how many terms did we get? It's 33 terms. It's going to be 33 over 2. What is our a? Our a is 2. What is our last term? Our last term is 98, right? So you must be very careful when we are dealing with combination, because this is quite challenging. So this will give me 1650. Then if I need to evaluate the following series, the whole series is the sum of arithmetic sequence 1 and the sum of arithmetic sequence 2. I just add them together, then I will be getting the final answer for the whole thing, right? So it will be 17 plus 1650. Then let's see, the final answer is going to be 3367 as the sum for the whole series. So you can see This was just a combination. That's why it's a bit of complex. You have to go determine n and all that. You have to be very, very careful, right? So that you can get the final answers. Sort of like a tricky question, but hopefully I hope now you now understand how you can do this. Okay. Okay, great stuff. This marks the end of our session. Don't forget we were doing session 6 and we were mainly focusing on a quadratic sequence and the combination of sequences. That is combination of arithmetic and geometric, combination of arithmetic and arithmetic, combination of geometric and geometric. Thank you very much for watching. Thank you very much for joining. And that's all for me. Enjoy the rest of your day. Goodbye.